Hi guys, and welcome back to the next lesson in our circle topic. Today we are going to be looking at sector area. So we're going to need another formula to be able to calculate the area of a sector. So hopefully we should all remember from last week and the week before, our area formula is given by pi r squared. So if we are looking to find the area of a sector, so let's say our minor sector, which is the small bit on the right hand side between A and B here, the area of that sector then is going to be the same area formula, pi r squared, but since it is a fraction of our full circle, it is going to be multiplied by x over 360. So that is the angle of the sector out of 360. So example number 1, we've been asked to calculate the area of this sector correct to two significant figures this time. So we're going to need to be careful with our final answer. So sector area is pi r squared times by our angle out of 360. So my radius this time is 9, so I can sub that in straight away. And remember, it is only our 9 that is being squared. Our angle is the 30 degrees and we are dividing it by the 360. That means we are doing pi times by 81 times by 30 and then dividing by 360. And that gives us 21.205. It was two significant figures, so I'm looking for the highest place values, so that is my 2 and my 1. The next digit then is a 2, so that tells us to stay the same, so it is just 21 centimetres to match my units, but because we are looking at area, we need a squared symbol there. So 21 centimetres squared is the area of this sector correct to two significant figures. For example number 2 then, we are going to do exactly the same thing. So this time I would like you to pause the video and see if you can have a go at this one yourself, and then play it and come back to check your answer. Okay, so first of all then, sector area is going to be pi r squared times by x over 360. So I'm going to have pi times by 7 squared times by 55 out of 360. 7 squared is 49 and it's still multiplied by 55 out of 360 is going to give me 23.518. Same thing as before then, my two highest place values are my tens and my units. The next place value, which is our 5/10ths, tells us that we need to round up. So it is 24. And then to check my units, it's going to be centimetres squared. Okay, for example 3, we have been asked to calculate the minor sector area to 1 decimal place. So hopefully we remember that minor means small, so we are calculating the area of this section here. That means then that we are going to need our formula once again, pi r squared times by our angle out of 360. So in this case, we are going to have 15 squared for our radius squared and 80 over 360 for our fraction at the end there. 15 squared is 225, still multiplying by that fraction at the end. And that's going to give us 157.079. It was to 1 decimal place, so that's going to be 157.1 centimetres squared for our final answer there. Hopefully we guessed then that we would move on and calculate the major sector area. So it's still the same circle, just this time we are going to be calculating this section. Our formula is still exactly the same, pi r squared times by x out of 360. Our radius is going to be the same, so that 15 squared, but this time we need to work out what our angle is. We know that a full circle is 360, so we are going to take away the other side of the circle, which was 80, and that's going to leave us with 280. So we've got 280 degrees on that opposite side. So our major sector area has 280 degrees for the angle. That means we're doing pi times by 225 times by 280 out of 360. And that is going to give us then 549.778, and to one decimal place then is going to be the 549.8 centimetres squared. This time we have been told that our sector area is 62.8 centimetres squared. We've been asked to calculate the radius to one decimal place. So this time we have been told what the sector area is. So I'm going to use my sector area formula. And I'm going to sub in the things that I do know. So we do know the sector area. We do know what pi is, so I'm just going to leave pi as it is. We don't know the radius, so we're just going to leave that as r squared. And then our angle was 72 over 360. The first thing I'm going to do then is bring my 360 up and multiply, because we're currently dividing on the right hand side. So 62.8 times by 360 is going to give me 22,608, and that's still equal to pi times by r squared times by 72. Doesn't matter what order you do it in, we want to get rid of our pi and the 72, because remember we're trying to get r by itself. So I'm just going to take my 72 over and divide. That gives me 314 is equal to pi times by r squared. I've run out of space, so I'm just going to write that again up here. So the next thing to do is divide by pi, and that gives me 99.949 equals r squared. We've been asked to calculate the radius though, not r squared, so I need to think, what is my opposite of squaring something? Well, that is taking the square root. So if I square root that answer, so I've not pressed clear in my calculator, I'm keeping exactly as it is, so 99.94930,426, and I'm just going to do square root, and then for me I can hit my answer button, and that square root's the answer that I've got on my calculator, and that's telling me then that r is equal to 9.997, but we've been asked for one decimal place, so r is actually going to be 10.0 centimetres, because remember radius is just a length, so I only want centimetres for my answer there. For example 6, an ice cream shop have made a new logo and they want us to calculate the area of their design. So the first thing that we've got then is a sector, so we'll want to find the sector area. I'm going to call this one triangle 1 and this one triangle 2, so that I can find all of the different areas. So I'm going to start off with my sector area then, is pi r squared times by x out of 360. We can see there that our sector area has a radius of 5, so this is the centre of my circle going out to the edge of the circle, so my radius is going to be 5, and the angle is my major angle there, so the 220 out of 360. That means we're doing pi times by 25 times by 220 divide by 360. That then is going to give us 47.996, and I'm just going to round this to one decimal place, but in actual fact that's going to turn into 48.0 centimetres squared for us there. Our area of triangle 1 is a half base times height, so my base of triangle 1 is going to be 6 and the height is 4, because remember the height goes straight from the bottom of the triangle right up to the highest point. 6 times by 4 is 24 and a half of 24 is 12, so I've got 12 centimetres squared. For triangle 2 then, still the same formula, a half of the base times by the height. My triangle 2 has the same base, so that's 6, but our new height is 15. So that's going to be a half of 90, which is 45 centimetres squared there. The last thing we need to do, I'm going to squeeze this in over at the side, is our total area. So that is going to be our 48 plus the 12 plus the 45, and that gives us 105 centimetres squared as our total area of the shape. Now it's your turn to try these questions. So question 1 is just calculating the sector area of each of these sectors to 1 decimal place. For question 2, you are calculating the area of the minor sector to 2 significant figures each time. And using the same 4 circles, you're then going to calculate the area of the major sector, again to 2 significant figures. Question 4 is a mixture, so you need to do the arc length from our last lesson and sector area to 1 decimal place for all 6 of these. So that's going to give you 12 questions to attempt here. You should have 2 answers for each of these parts. And then question 5 is an extension question. So if you have flown through the rest of those questions and want an extra challenge, question 5 is an exam style question for you to have a go at. Well done for sticking with today's lesson. Try your best, and I will see you in the next lesson.